Alright, so we're going to have another look at a question from the 2020 HSC Advanced Maths paper. This is question 23. So this is a continuous random variable question. So we have some continuous random variable x has the following probability density function. Alright, so this is question 23. We have the probability density function f of x is equal to the piecewise defined function sine of x if x is between 0 and k, including 0 and k, and it's 0 everywhere else. So this is 0 all other x. So we need to find the value of k. Well, if we draw the sine function, so we have just the positive sine function, the bit of the sine function on the right of the y-axis, because we're starting at 0. This does this, and then goes down, and then carries on. The only bit we're going to be concerned with is this bit, because these probability functions need positive areas. So we can't count any of this. This will not count. So the k is going to be somewhere between 0, this goes up to 1, somewhere between 0 and pi. And in fact, it's going to be, we're going to find it. So we're going to find this by letting the integral from 0 to k of sine of x dx be equal to 1. Because the total area under the probability density function, the bit that's not 0, has to be 1, because that's 100%. So we'll do this integral and solve for k. So we have the integral of sine of x, well that's sine of x to differentiate to cosine, so it's going to integrate to minus cosine of x from 0 to k is equal to 1. So we'll evaluate this. We have minus cosine of k minus cosine of 0, so that's plus cosine of 0 is equal to 1. Now cosine of 0 is of course 1. This is 1. And this gives us that minus cosine k has to be equal to 0. Now, if you think about this, minus cosine k equals 0 is actually the same as cosine k equals 0. Cosine k equals 0. And now we're trying to find a k value that makes cosine equal to 0. Well, the only value between 0 and pi that does that is pi on 2. So this means k is going to be equal to pi on 2. And that's going to be our solution here. So that is the value of k that makes this a probability density function. Now we're asked, find the probability that x is less than or equal to 1 and give your answer correct to 4 decimal places. Okay, so when we're doing probability densities, to find probabilities, we have particular formulas for these. We've just calculated what k is. It's asking us about a particular probability. And so we're going to do a very specific thing using our knowledge of this probability density formula, of this probability function. We'll just call it a probability function. That's a more generic word to describe it. So this was all part A. And now, when we're doing part B, the probability of x is less than or equal to 0. All right, probability capital X is less than or equal to 1. So this is what we're after in this case. So let's write down the method that we need for this. So there's a few formulas on the formula sheet that are often relevant for these questions. We don't actually have to use any formulas in this case. We're just going to be taking an integral. We know that the probability function sort of does this, then goes down to 0, then carries on. It's 0 over here, 0 over here. This is pi on 2. Now remember, pi in its number form is 3.14. 3.14 divided by 2 is about 1.5, 1.6, something like that. So this is about 1.2 6-ish. And we want the probability x is less than or equal to 1. Well, 1 is about here. So that is going to be this area. This area under this curve will correspond to the probability. And so this is actually just going to be the integral from 0 to 1 of the function sine of x. Because we're just after the area. This total area is 1, so we can just take this integral and this will give us the probability. We don't even need to modify it. So this is going to be minus cosine of x evaluated from 0 to 1. So this will be minus cosine of 1 plus cosine of 0. Cosine of 0 is of course 1. So this will be 1 minus cosine of 1. You can then put this into your calculator. Cosine of 1 is not necessarily going to nicely evaluate. So we can just compute this with a calculator. This will give us 0.459 ... So it says 4 decimal places. So 459, the additional decimal place will be 7. So when we round this, this will be 0.4597 to 4 decimal places. And this is the answer. So this is the probability that x is less than or equal to 1 in this particular case. Now let's have a quick look at the marking. The marking is fairly straightforward. It's 2 sections, each worth 2 marks. So the first part, using the integral to try and solve for the value in some fashion, is going to get you a mark. So long as you can somehow set this integral up, attempt to solve it, that'll get you 1 mark, or some kind of equivalent merit. You need k is pi on 2 in order to get the second mark. For part B, if you can identify that the probability is going to correspond to a definite integral, or some equivalent merit, this will get you the first mark. Then correctly evaluating and providing a solution is going to get you the second mark. So that's going to be these 4 marks. This is a continuous random variable question. This one is reasonably simple. You don't need the formulas from the formula sheet to do this, right? There's a lot of debate over whether this should be put in the HSC curriculum when it was put in the curriculum. One of the strong defenses of this by one of the commentators, one of the expert contributors to the curriculum, was that a lot of continuous random variable stuff is just calculus. Right? So this whole question pretty much is just doing integrals and then doing some algebra after you've done the integrals. Right? So looks like a stats question, probability question. It's really not. It's really just an integrals question.